Okay, so today we're taking a look at finding measures indirectly by applying properties of similar figures. There are times where we just can't measure distances or heights directly just because of not having the tools. So when that happens, we can actually measure distances using a method of indirect measurement and similar figures and proportions to then find measurements that we can't directly measure. Let's start by looking just a basic application. Here we have two triangles that are similar. We want to find the length of side EG, looking at what we have here already. So remember, with similar figures, we have to compare the same sides. So here, the ratio of 3 to 9, or BA to FE, has to be the same as 4 to X. And now we're just looking at a proportion like we've been doing. So we can do our 9 times 4, which would be 36, and then divide that by 3, which is going to give us 12. So here, X is going to equal 12 feet. So now it's your turn to practice. Why don't you go ahead and pause the video and try this one out. So here, we have 2 to 8 has to be the same as 7 to X. So I'm going to do 8 times 7. Has to be the same as 2 times X, so this would be 56. We divide by 2, and this becomes 28 is equal to X. So X is equal to 28 inches. Now let's look at a problem-solving application of one that we would actually use in real life. So a 30-foot building casts a shadow that is 75 feet long. A nearby tree casts a shadow that is 35 feet long. We want to know how tall the tree is. One way I like to do this is by drawing a picture. So here, if we have our building, and it is 30 feet tall, it's casting a shadow that's 75 feet. So really, we're creating a triangle. So now I have a tree that's nearby, same type of day. We don't know how tall the tree is, but we know that its shadow is 35 feet. So now we can set up our proportion. 30 is to X is the same as 75 to 35. So if we go ahead and use our cross products, so I'm going to do 30 times 35. I get 1050, and that has to equal our 75x. So now I'm going to divide by 75. So we get that 14 feet is equal to X, so the height of the tree is 14 feet. So now it's your turn. Why don't you go ahead and pause the video and see if you can solve this one on your own. Alright, so we have a 24-foot building. So here's my building. It's 24 feet. And it has an 8-foot shadow. And here's my tree. We don't know how tall it is, but its shadow is 3 feet. Now once again, remember, it doesn't matter how you set up the proportion as long as you set up ratios of the similar sides. So here I could do X is to 24 is the same as 3 is to 8 because I'm comparing similar sides. So I'm going to cross multiply, so I have 24 times 3 is the same as 8 times X. 24 times 3 is 72. If we divide by 8, then we know that X is equal to 9 feet. So the tree is 9 feet tall. Another application that you'll sometimes see is doing distance across rivers and things like that. So Vilma wants to know how wide the river near her house is. She drew a diagram and labeled it with her measurements. How wide is the river? So I want you to see if you can figure out this one on your own. So if you think about the fact of the triangles kind of being flipped and opposite each other, we know that this is our right angle. 5 is the same as the 7. That's going to be our legs, our bottom leg. So 5 is to 7 is the same as 5.7 to X. So I'm going to do the 5.7 times 7, and we get 39.9 meters. Is equal to 5x. So I'm going to divide by 5, and we get 7.98. Or if we round it, it's going to be about 8 meters across.